Okay, so here's a second video on covalent bonding. The first one showed the examples kind of maybe a little nonchalant with counting the total electrons at the beginning. This time it's going to be extremely important because people are going to want to put bonds other places and add electrons to make things work out that should never really be there. All right? So the first example in this second set is CH3 Already looks a little bit difficult, all right, compared to the old ones. So 1, 2, 3, 4 hydrogens, and then a carbon. 1, 2, 3, 4. So if we add up the total electrons, we have 1, 2, 3, 4 plus 4 here, that's 8. Now my recommendation is, in this situation, whenever we have an element by itself, like we have 4 hydrogens and 1 carbon, let's put the one that's single in the middle. See, I already did not draw it the way we typically would, okay? But that's okay for now, right? Normally we have 2 valence electrons here and then we go around. But we have 4 hydrogens, so we have 4 sides of the carbon. So where do you think they're going to go? I'll tell you what, I'm going to draw it like this for now. This might help us see it a little bit better. Okay? So let's check our carbon. Does it have 8? Right? You're going to say, no, it still has 4. Well, we have to count the one from hydrogen too, okay? So 1, 2, 3, 4, 5, 6, 7, 8. 8 for the carbon, and then each hydrogen has a single bond with it, so that's perfect. Now look, total 8 electrons here, total 8 here at the beginning. You see how it has like this symmetrical look to it? A lot of times when we have ones like this where there's a single one and then others, you're gonna have some symmetry. Next one, water, H2O. All right, so which one's gonna go in the middle? O, all right. So hydrogen each has 1, then our oxygen has 6. 1, 2, 3, 4, 5, 6. So 6 plus 7, 8, that's 8 total electrons. Total E, 8 electrons. So let's put our oxygen in the middle, and let's put our hydrogens on the outside. Have the symmetrical look. If it's your instinct to maybe put one up top and one on the bottom, okay. All right. Typically when we see it right now, it looks like this. So oxygen has originally 6. So it needs 2 extra ones. All right. So here's my hydrogen, and here's my oxygen. So look at our oxygen. These combine 2, 4, 6, 8. 8 on the oxygen, 8 total electrons. Now if we'd write these out, draw these out the way we did for the other stuff, we'd have it look like that. Okay? So I always look at the one that has a line. I don't look at hydrogen because I know hydrogen is always a single bond. But I look at the other one. I say, oh, there's 6. So we must have 2 bonds somewhere because we need to add an electron there. Share up an electron. See our 2 bonds. Okay, example 3. C2H4. So 2 carbons and 4 hydrogens. 1, 2, 3, 4. And carbon each has 4. Okay? 4, 8. 9, 10, 11, 12. So there's 12 total electrons. 12 total electrons that we have to use. So we have 2 carbons and we have 4 hydrogens. So if we're looking for symmetry, how many hydrogens do you think are going to be in each carbon? Probably 2. And we know each hydrogen has one bond. Okay, so this is good for the hydrogen. Now we need to figure out the carbon. So let's count this carbon, 2, 4. So we need 4 more. 2, 4, 6, 8 for this carbon. 2, 4, 6, 8 for this carbon. So each carbon has 8. Each hydrogen has the single bond. Let's count them up. 2, 4, 6, 8, 10, 12. 12 total electrons. It's perfect. Each carbon has 8. Each hydrogen has really 2. And then one last example. This one's a little bit different. CH3 Br. It's hard to get a lot of examples for covalent, all right? So you're gonna notice that there's different ones, but they're very similar. So carbon is 4, hydrogen has 1, and bromine has 1, 2, 3, 4, 5, 6, 7. Right? 7. There we go, 7. So I'm gonna just draw this one, okay? We have a total of 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons that we can use. So let me look at my notes. So carbon, hydrogen, hydrogen, hydrogen. Bromine, 1, 2, 3, 4, 5, 6, 7, 8. Just make noises and hopefully it works out. Well, let's check this. Each bromine one has 2, 4, 6, 8. Good. You have to have 8. Carbon, 2, 4, 6, 8. Good. Hydrogen, 2 each, 2 each. But let's just make sure that we use only 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 electrons used here. All right. So I want to go back here real quick. It's kind of a long video, a couple videos. But I want to talk about the types of bonds here. These are 4 single bonds. 4 single bonds, right? We didn't have these electrons all next to each other. There's only 4 bonds, all single. Over here, 2 single bonds. One for the hydrogen, the other one for the hydrogen over there. This one, which did I not finish? There we go. Okay. I made a small mistake in the other one, so I had to redo it. Now this one, single bond, single bond, single bond, single bond. So 4 single. And in the middle, what's that? So single, 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 and this is 1 double bond. The double bond's right here in the middle. You have 2 pairs. 2 pairs means it's a double bond. And then lastly, this one, we have a single, a single, a single, and 2 electrons, 1 pair, single. So we have 4 single bonds in that one.